Okay, this is our final video for section 4.1. As we ended our last video, something wasn't quite making sense with the math that we had come up with, and so I spent a second and quickly realized what the error was. And my error is here in my sign chart. The positive sign here is correct, but I said we should plug in a number like -1 between, which is what I said was between negative root 2 and negative 2. But root 2 is, 1 is on the other side of that. So what I really need to do is pick a number between negative root 2 and negative 2. Let's just make it simple and plug in something like negative 1.999 and see what happens with that. So if we do that, again, the denominator is always going to be positive, but the numerator this time, I plug in a number that's almost -2, which gives me a number that's almost 4, and I can see I've got a number of 4 minus almost 8, which is negative. So the mistake that I made was not in any of the calculus, but in rushing, trying to get this video in under 20 minutes. In fact, these are both negative values. So that means my slope is not positive coming off of this value at -2. It's in fact negative. Furthermore, should have also noticed that back at the beginning, if I plug in 0 for x, clearly I get a point of 0 here. And so what that means is at negative root 2, I've got a minimum down here someplace because my slopes are negative, and then there's a slope of 0, and then we're positive all the way up until positive root 2, and then my sign chart tells me I switch down to negative, heading back to 0. And so with that evidence, now I know that we have a local maximum at -2. We have a local minimum at negative square root of 2, and I haven't found the y value, but you can do that. We have a local maximum at positive square root of 2, comma, find the y value. And ending with a local minimum at 2, 0. Okay, so we got a little messy on that problem. Don't like videos or problems expanding over 2 videos, but that's what we got. Okay, 2 more to go. Hopefully these will go quicker. Let's change colors. All right, so quick analysis of this led me to a domain of up from -infinity to 3. I plug in 3 and I get 0. Plug in something bigger than 3 and I'm undefined. So that's where I came up with this domain. All right, so let's take the derivative. 2x times the square root of 3 minus x plus x squared times 1/2 times 3 minus x to the -1/2 times the derivative of 3 minus x, which is -1. So my derivative is 2x square root of 3 minus x. Okay, I have a negative, so that turns into minus. Nothing cancels, so it looks like I have an x squared on top. And on the bottom I have a 2 because of the half, and then the square root of 3 minus x. So I need a common denominator. So this guy needs the same denominator, so I got to multiply top and bottom. And so when I do that, I get a denominator. And my numerator, I've got a 2 times a 2, so that's 4x. The square root and the square root cancel out, and I get 3 minus x squared, or 12x minus 4x squared minus x squared. And finally, whoa, got away from me. The derivative equals, let's see, let's go with negative 5x squared plus 12x over the bottom. Okay, when does the derivative equal 0? Only when the numerator of the fraction equals 0. Factor out an x. So I get x equals 0. X equals, subtract, divide, looks like positive 12/5. When is the denominator equal to 0? Would answer the question, when are we undefined? So when's the denominator equal 0 would be at 3. But once again, notice I was checking 3 anyway. Alright, let's come over here and do our sign chart. Again, of the derivative. We want to look at the slopes. Alright, so 3 is the biggest I can go because my domain stops at 3. I've got negative 12/5. I'm sorry, positive 12/5, which is 2 2/5. And I have 0 as critical values. So now it's time to do a sign chart. So let's analyze my derivative, which is over here. I plug in a number like negative 10 billion. The denominator would be positive. The numerator, negative number squared is positive, so I've got now positive 10 billion squared times negative 5. Long story short, that should be negative. So negative divided by a positive. Number between 0 and 12/5 would be a number like 1. The bottom is going to be positive. The numerator is going to be negative 5 times 1 plus 12. So that's positive over positive. And then I plug in, let's see, that's 12/5. Let's plug in like 2.9999. See what happens there. At 2.999, the bottom is positive. The numerator, so a number that's almost 3 squared is almost 9, which gives me a number that's almost negative 45, plus, plug in a number that's almost 3, gives me a number that's almost 36, and so it looks like I have a negative over a positive. Alright, so there's my sign chart. So now I know that there is a local minimum at 0, 0, I guess. Plug in 0 to the original function. And I know it's a minimum because my slopes are negative. And then at 0, my slope is 0. Then I go to positive. So I went down and then up. That means I have a local maximum. At x is 12/5. And the y value would be the local maximum. I'll let you figure that out. And then I go back down to 3, which is 0. So I went back down to 3, which means that would be a local minimum as well. So I have 2 local minimums and 1 local maximum. Alright, 9 minutes. Let's do the last of these. We have a piecewise function. So, first thing I want to do is I want to see what's going on at 0. I want to know if this function is continuous or not. So continuous, question mark, would mean does the limit as we approach 0 from the left equal the limit as we approach 0 from the right? Which means simply plug in 0 to both of them, and on both of them I get 3. So they are continuous. So now I need to figure out what's going on with each of them. So I'm going to find the derivative, but I'm going to do it as a piecewise function. So I'm actually going to find 2 derivatives. So the derivative of the numerator is simply going to be negative 1, because it's linear. and that's going to be for all values less than 0. For all values greater than 0, I'm going to find the derivative, and I get negative 2x plus 2. Now you notice I didn't put or equal 0 here because I wasn't sure what was going to happen yet. I know that the slope on the left side is negative 1 as we approach 0. It's always negative 1. And on the right side, it varies, but as at 0, I plug it in, I get a 2, which is not the same as negative 1. So that means the slopes on the left and the right at 0 don't match, meaning at x equals 0, we've got a corner or a cusp. Let's call it a corner. All right, and we'll look at a graph of this thing in a minute. All right, so now the question is, we know there's a corner or cusp happening at 0. Within each of the individual halves, though, do I have any critical values? Since I want to know when the derivative equals 0 or undefined, notice the undefined is my corner. For x is less than 0, the derivative is always negative 1, therefore it's never 0. And the derivative of negative 2x plus 2 would equal 0. Move the 2x over at x equals 1, which is part of the region it's graphed in. So I have another critical value. All right, let's see what kind of a sign chart we can create with this bit of a mess. I know there's a corner at 0, which means my derivative is undefined because the slopes didn't match. And I found a critical value at 1 because my slope was 0 there. So now the slopes on the left side of 0 are always negative because it's negative 1. Between 0 and 1, that would be a derivative found by the bottom half. So I plug in a number like a half, and I get negative 1 plus 2 is positive. And I plug in a number bigger than 1, like 10, and I get negative. So the information says I have a local minimum at 0 and a local maximum at 1. Again, plug the values back in to find out what they actually are. Okay, now let's just quickly take a look at this graph and see if it matches what we know to be true. All right, at 3 minus x, the y-intercept is 3. The slope is negative 1, so that means I'm coming down with a slope of 1. So that's 3 minus x. And then I switch over to this quadratic, which we know is upside down, has a y-intercept of 3. We don't know where the vertex is yet without doing a little bit of math, but based on what I found over here, I know that 1 should be my vertex. And it says that I'm coming down, then my slopes are positive until they're 0 at 1, and then my slope is negative. So what that tells me is this little vertex here is at 1 comma something or other. So that matches what we found. My corner or cusp here is a minimum, a local minimum, and then 1 whatever is my local maximum. And again, I'll leave you to find the y values. Alright, so that concludes all the problems I'll be talking about. Oop, that's minimum. I'm going to leave the last ones for you to do on your own. And hopefully you found some value in this. And goodbye.